Here is an example based on the auto transformer. So the auto transformer N1 equal 20 number of turns, N2 200 number of turns, V2 120 volts, and impedance of the load is given. So the question he's asking about, find the transformer ratio, primary voltage, power supplied to the load, power supplied by the induction and conduction of an ideal auto transformer. Assume that transformer is running at full load. So step 1, for every transformer I'm going to find N. N is nothing but transformer ratio. Here my secondary number of turns are N2 200, so I see secondary is connected between only secondary coil or common coil, which is 200 turns, and the primary is connected between N1 and N2, so the total number of turns are 220. So N equal to 10 over 11. Based on that, I can find V2 over V1, which equal to N, which is 10 over 11. So I end up finding V1 equal to 132 volt. Okay, so I found the transformer ratio and primary voltage. Now power supplied to the load. To find the power supplied to the load, what I'm going to do, I'm going to find the current I2. I2 equal to V over Z. V is known, 120 volts, divided by Z is 12 plus J13. So I found I2 equal to 6.783 at an angle of minus 47.29. Now I found the rating of the transformer, S equal to V2 times I2 prime, or you can say V1 times I1 prime, or I1 conjugate. Okay, I2 conjugate, I1 conjugate instead of prime. Now I end up finding that value as 813.96. okay, I also took the angle because so that I can separate the P2 and Q2. Now the apparent power or rating of the transformer is nothing but apparent power 813.96. This is the rating of the transformer. Now what I'm going to do, I'm going to separate this as an individual single transformer. When I separate it, all I'm going to do, here is my primary number of turns, I have 20, and secondary number of turns 200, and here I have 120 volt. Okay, that's all I know. And based on the turns ratio, I can tell the voltage here is 12 volt. Now what is the current each coil can carry? So look at this here, this common coil is going to act like a secondary, and this coil, series coil, is going to act like a primary. So this is primary coil and this is secondary coil of ordinary transformer. Now I know that this I1 current is coming down, IC current is going up, and I2 is going out. I already found I2. I know I2 value. So all I need to know, find IC and I1, so I know what is the maximum amount of current each coil can carry. To find that, I used I1 plus IC equal to 6.783. So I already found this current as 6.783 ampere, and so I1 plus IC must be 6.783 ampere. So if you look at the transformer, so here I2 is going up, out, I1 is coming into the junction, IC is also coming into the junction. So IC plus I1 must be equal to I2. I already have I2 value as 6.783. So this is one equation. I need one more equation so that I can find the relation between I have to have one more equation with relation between IC and I1 so that I can find I1. My goal is finding I1 in this case. So what I did, I used the transformer ratio. So IC over I1 must be 20 over 200. Okay, so basically if you look at the ordinary transformer, this is I1 the current going out is IC or I2 in the ordinary transformer case. So that value I end up with 11 IC equal to I1, sorry, 10 IC equal to I1. Okay, so I substituted this 10 IC in this equation. I found IC equal to 0.616 and I1 equal to 6.16. So I found the ordinary transformer rating, which is 120 times 0.616. So the current the secondary can carry, maximum current the secondary can carry is 0.616, and the current the primary can carry is 6.166. So the rating of the transformer is 120 times 0.616 or 12 times 6.16. So the rating of ordinary transformer is 73.96 volt ampere. So the amount of apparent power transferred through the induction is whatever power transferred through the ordinary transformer, which is 73.92 volt ampere. Amount of apparent power transferred through the conduction, which is rating of the auto transformer, which is 813.79 minus 73.92. So the amount of apparent power transferred through the conduction is 739.87 volt ampere, and from there you can find power. I'm not too much worried about this calculation, but once you know S value, P is nothing but S times cos theta. So power supplied or power consumed by the load by conduction principle is nothing but S conduction times cos theta. It is 547.31. Power consumed by the load by induction principle is 73.92 times cos theta, 54.68 watt. Now here is similar example. Here also you see it's ideal transformer, but on the primary side we have some impedance and load impedance on the secondary side. Now step 1, I'm going to find the ratio N2 over N1. So based on that I end up with finding V1 value, V1 equal to 132 volt. I also found I2, since I know the voltage drop across the load and load impedance, so I found I2 as 24 at an angle of minus 36.86. Found I2 and the and V1 value. V1 is right here. V1 is different than Vs because there is a impedance right there. Now by using the transformer ratio, I found I1 over I2 equal to, it's just opposite to the V2 over V1. Okay, it is still valid, doesn't matter whether it is auto transformer or regular transformer. I found that current I1 equal to 21.89 at an angle of minus 36.86. Now loop 1, apply KVL. I applied KVL in loop 1. So if you look at loop 1, minus Vs source voltage plus 3 minus J1 I1 plus V1. I already have V1, I'm going to substitute that. I already have I1, I'm going to substitute that value here. So I end up finding Vs equal to 180.4 at an angle of minus 18.30. Now I'm going to separate it as an ordinary transformer. So the primary has 10 turns, secondary has 100 turns. Now I'm going to find I1. Probably this is the common current. So here you can see I know I2 value, which is 24 at an angle of minus 36.86, and I know I1 is 21.89 at an angle of minus 36.86. So the phase angles are same, so IC must be 2.19 at an angle of minus 36.86. So that's how I found the current the secondary coil can handle. I also found current the primary coil can handle. So based on that, I found apparent power transfer through the induction principle is whatever the rating of the ordinary transformer, which is 262.68 volt ampere, and the apparent power transfer through the conduction is rating of auto transformer minus rating of the ordinary transformer, which is 2617.32 volt ampere. With this, I'm done with auto transformer. Next video, I'm going to make three-phase transformers, or I'm going to talk about three-phase transformers. Thank you.